Hi folks, today we're going to be setting up a basic Ospf topology in Packet Tracer. This is Packet Tracer version 7.3.1. Getting straight into it, first thing you're going to need is some routers. So you're going to want to go to Network Devices, Routers, and for this we're just going to use the router 4331. You can just drag and drop them if you prefer, or alternatively you can hold down the control key and click on it, and this will let you drop them in like this. Alternatively, just letting you guys know ahead of time, I am going to be configuring the interfaces and labeling everything right now, so if you prefer to skip all that, I will be leaving a timestamp in the comments in the description that you can jump to the actual part where I'm setting up OSPF if you'd prefer to do that. Otherwise, you can stick with me here, and I will be just doing the interface configurations here. So I'm labeling the routers here. So we got R1, R2, R3, R4. Yep. And next thing we're gonna do is cable them up. So for as far as cabling, you can use a straight through cable or a crossover cable. Either one of these will work. Straight through still works due to MDIX, which is supported on these routers. So that's what I'm going to be using here. I'm just going to cable them up real quick. Okay. And make sure it's kind of neat, somewhat. Good enough. So next thing we're going to do is label the networks. So for this topology, there's going to be 4 different networks connecting all 4 of these routers. So there's going to be a network there, there, and then there. But just going to label them here. So the first network is going to be 172.1.1.0. It's going to be a /24. In fact, all of these networks are going to be a /24, just to keep it nice and simple here. I'm going to label the hosts as well for this network. So this will be, router 1 will be .1. And then this interface on router 2 will be .2. That's going to be the same on each of these networks. Just a quick tip. I kind of did that kind of fast. Quick tip here. If you hold down the control key and then go to this text and then just do the drag and drop, it'll actually make a copy of it for you. That's kind of handy if you're labeling a bunch of things like I'm doing it right here. For this network over here, it's going to be 172.1.2.0. And then the hosts are going to be the same. I can just do the control and drag like that. Okay, again, control, drag for this network down here. Okay, for this network, it's going to be 172.1.3.0. Like that. And actually, I got an idea. We'll just do this. Whoop. Bad idea. Oh, there it goes. Okay. Alright, and once more for the final network over here, which will be 172.1.4.0. Like that. And we'll just drag like this for the hosts. Alright, so we're all labeled here. We're going to go ahead and start configuring the interfaces and getting all this out of the way. Okay, so we're going to hit No, Enable, Configure Terminal. Now the interface on router 1, the first one is going to be interface G000. I'm going to go No Shutdown. Configure an IP address of 172.1.1.1 with a subnet mask of /24. Okay, next interface will be interface G001. No shutdown, IP address 172.1.4.1. Okay. If you want to verify your work, you just do a do show IP int brief from global config mode, and that'll show you your interface assignments there. Okay, moving on to router 2. Okay, no, enable, configure terminal, interface G000, no shutdown, IP address 172.1.1.2. Okay, next interface will be G001, no shut, IP address 172.1.2.1. Okay. Make sure they're looking good. Okay, looks good. Next thing we'll do is router 3. CLI, no. Configure terminal. Alright, interface G000, no shut. IP address 172.1.4.2. Okay. Next interface. Oh, let me do the no shutdown first. That's how I prefer to do it. IP address 172.1.3.1. Okay. That looks good. And finally, router 4. Interface G001, no shut. IP at, whoops, address 172.1.2.2. And next interface, IP address 172.1.3.2. Okay, I think we're good. Just to make sure, I'm going to do a couple of ping tests here just to make sure I didn't misconfigure anything. Let's see. So we're going to ping 172.1.3.1 over on router 3. That should be successful. Looks good. Also going to ping router 2 over there. 2.1. See, make sure that works. Looks good. We're going to jump over to router 1, do a couple ping tests, just make extra sure here. Just want to make sure I didn't misconfigure anything, which I have definitely done in the past. So, okay, ping 172.1.1.1. Okay, looks good. And then 4.2. Okay, looks good. Alright, so we got everything labeled and all the interfaces are set up. At this point we can go ahead and jump into the Ospf part of the video. We'll start with router 1. So with Ospf, for the router ID we're going to be using a loopback interface. I'll set that up first and then I'm going to talk about the how the different RIDs work and how to set those up. But just to start with the loopback interface, it's going to be interface loopback 0. And that'll automatically change to up, so we don't have to enter the no shutdown command. We do have to give it an IP address, so IP address, and for router 1 it's going to be 1.1.1.1, and then the subnet mask is going to be all bits on, so basically a /32 for the subnet mask, like that. And if we want to look at it, we can go show IP in brief, and there's the loopback interface right there. And so as far as the router ID, in Ospf, there's 3 different ways a router ID can be assigned. The first way is just you manually type it in using the router-id command, and that lets you manually configure the router ID. The second method is just using a loopback interface, which is what we're doing. So the loopback interface, the router ID when we configure Ospf is going to be 1.1.1.1, which is the way I prefer to do it with the loopback interface. The third method, if you didn't manually enter the RID or configure a loopback, Ospf is just going to use the interface with the highest IP address, in which case this will be this one. So if we didn't do any of those previous steps I mentioned, this will be the router ID. But so at this point we've configured the loopback interface. Now we can go into configuring Ospf. So it's going to be, the command is going to be router Ospf and then whichever process ID number you want to use. We're going to use 1, but as far as the process ID in Ospf, the process ID is going to be unique to each router. or it's only going to pertain to each router, meaning it doesn't need to match on every single router. In other words, I could configure an OS process ID of 1 on this router, and then a process ID of like 6 on this router, and then 8 on this router. It wouldn't matter. In the same context, they could all be the same router ID. I'm sorry, the same process ID of 1, and it would work just the same. Just some information there. So router OSPF 1 is what we're going to use on each of the routers, just to keep it simple. And here are all the commands we can enter here. So like I mentioned earlier, if you want to manually configure the router ID, there's the option there. But like I said, in this case, we're using the Loopback connector, the Loopback interface. And what we're going to be using is the network statement. So it's going to be network, and then the network number. So for the network number, it's just going to be 172.1.0.0. And what we're going to be doing is telling OSPF to only match on this part that we specify here. And we're going to specify this using the wildcard mask, which we're going to be configuring here in a second. But basically, with the wildcard mask, which is what it's going to ask for next, it's going to be 0.0.255.255. And what the wildcard mask basically does is it tells OSPF what part of this statement here is OSPF going to match on, as far as networks. So the 0.0 part, let me make this clear here. The 0.0 part of the wildcard mask is basically telling them match on these bits. So in other words, it's telling OSPF to match on 172.1 part of the network. Which the reason I'm doing that is because that applies to every single one of these networks. Every single one of these networks starts with 172.1. So in that sense, we only need one network statement. If I wanted to have multiple network statements specifying each one of these networks, 172.1.1.0, 172.1.2.0, etc., I could do that. But I'd prefer for this lab just to keep it nice and simple. So in this case, we're just doing this here, 172.1.0.0, and with this wildcard mask. And then we need to specify the area, and the area number we're going to use is 0, and the area number needs to match on every single one of these routers. If one of them, let's say, is set to 0, and then one of them is set to like 5 for the area, that's going to cause a problem in OSPF, and then you're going to have an issue where adjacencies aren't being formed. So make sure that each router is set up with the correct OSPF area. And that's the network statement. And that's pretty much it for router 1. We're going to move on to router 2. And the process is pretty much the same on all 4 routers. First thing you're going to do is set up the loopback connector. So it's going to be interface loopback 0. Automatically switches to up. Let me just give it an IP address. So again, with the loopback connectors, I usually just give it the number that matches the name of the router. So we're doing router 2, so we'll just do 2.2.2.2. All bits on for the loopback. So /32, like that. I'm going to verify it's there. You can do that like that. Loopback 0. Okay, now we're going to configure OSPF. So router OSPF 1. And then the network statement. Network is going to be 172.1.0.0, 0.0.255.255. So again, matching on 172.1. And don't forget to include the area 0. Okay, that's it for that. Just additional information here. If you want to verify that OSPF was configured properly, if you go to show run include section OSPF, it'll give you the commands we entered here. We see router OSPF1, the logging command there, which is default, and then our little network statement here. So that's one way you can verify that. But that's pretty much it for router 2. We'll move on to router 3, doing the same general process here. Let's see here. Interface loopback 0. IP address for the loopback on router 3 is going to be 3.3.3.3. All bits on for the subnet mask. Okay. There it is. Router OSPF 1. Okay, and the network statement is going to be 172.1.0.0, 0.0.255.255. Area is going to be 0. Alright. And finally, we'll move over to router 4. Okay. Interface loopback 0. IP address for router 4 is 4.4.4.4. Okay. There it is. Router OSPF 1, network 172.1.0.0. Wildcard mask, area 0. Okay. Alright, so at this point, if we give it a second here, we'll see that adjacencies, we're on router 4 right now, an adjacency is going to be formed with router 2 and router 3, and the same thing would have happened with the other routers we configured. And we can see these two log statements here that just popped up here. So we're on router 4. It's basically telling us, it gives us the process ID in OSPF, but it's giving us this router ID here, router 3.3.3.3, which we know is just router 3. The same goes for router 2. It's basically just saying that, we've established an adjacency with these two routers successfully. Well, that's pretty much it. So at this point, OSPF has been configured. If you want to verify this, again, you can do the show run include section OSPF, and that'll give the statements here. But another way to get some additional information, if you do show IP route command, you'll notice that there are a couple of routes in here that have been added from OSPF, and they are noted by the letter O for, obviously OSPF. If you want to make this a little easier to read, you just go show IP route OSPF, and then that'll just give you the OSPF routes right there. And we can see here, these networks here previously were not in the routing table for router 4. So we can see this 172.1.1.0 is over here, and then 172.1.4.0 is over here. So if we want to test this, we can ping one of the interfaces on router 1. So we'll say 172.1.1.1. It's successful. And we could ping the other interface, see if we can reach it, 172.1.4.1. There you go. So at this point, we do have full adjacencies formed with all of them. Getting into some of the show commands you can use with OSPF. If you do show IP OSPF, here are some of the show commands. You can enter the process ID number, of course, and that'll give you some information, such as the the RID, some other information here. Let's see. Neighbor will note the neighboring, the adjacencies that are formed with each of the neighbors here. So we can see with router 2 and then router 3 right there. So, and probably one of the more useful OSPF show commands is going to be the interface. Show IP OSPF interface command, and then you enter the interface. For this, we're going to use G001 interface. And this gives us a lot of useful information here. So first off, it just gives us, the interface, letting us know it's up, the interface address, the process ID, and our router ID. But it tells us that this is a broadcast OSPF network. So for a broadcast, that is going to be default on Ethernet links and fiber links. So FDDI for fiber. Those are both all going to be configured as broadcast in OSPF by default. We can change that. However, by default, like I said, that's what it's going to be. If you have a point-to-point link, that's going to be set up for point-to-point network by default in OSPF. so we don't need to change it or anything. It automatically configures it, and it gives us the cost of the link, priority. But other good thing this command does is gives us the DR and BDR, letting us know that the DR is 2.2.2.2, which is router 2, and the BDR is going to be 4.4.4.4, which is router 4. And that also lets us know the hello time interval and the dead time interval as well. Just keep in mind that for broadcast networks, the hello interval by default is going to be 10 seconds, as it's shown here, and the dead interval is going to be 40 seconds. So that's pretty much it as far as the show commands and a basic configuration of OSPF. There are some other show commands you can use, but I'd say those are the most common you would use. There's also database, which gives some additional information here. But that's pretty much it as far as a basic kind of configuration of OSPF. I will be making another video talking about how to configure the reference ID, so that way OSPF will actually differentiate gigabit Ethernet links and fast Ethernet links, because by default those are basically the same cost in OSPF by default out of the box. So how to change those, and as well as changing the default route and allowing that default route to propagate throughout the network. I'll have separate videos for those two topics. But anyway, that's pretty much it. If you enjoyed the video or you found it was useful, please like the video, and thank you for watching.